Hey Algebra 1 class, this is your first flipped notes video presented to you by Mr. Biney. So as you can see, this next chapter is all going to be about quadratics. So quadratic functions, quadratic graphs, how to solve quadratics. But today we're just focused on their graphs. So first we'll start with what is a quadratic function. So if you think back to the last chapter, we were dealing with all sorts of polynomials. So for example, 6x squared plus 8 could have been a polynomial we might have been working with for a little bit. So if we had to classify this based on its degree, that was all those fun words you guys loved so much, this was a quadratic. And where did we get those from? We looked at the biggest exponent. So an exponent of 2, or x squared, told us that it was a quadratic. So the only difference now to make it into a function is going to be, we're going to put a y equals out in front, because then we have an equation. So our standard form, just a generalized form, is going to be y equals a times x squared plus b times x plus c. And each of those a, b, and c letters are all just constants. So in constants. So in your equations that you'll be working with, so if I just pull up the equation from the bottom of the notes sheet, the first one, that's y equals x squared plus 6x minus 2. Our a value is always just going to be the number out in front of the x squared. So here our a is going to be 1. If there's nothing out there, there's just a 1. Our b value is whatever's in front of that x. So here our b is 6. And our c value is that number hanging out there on the end. So our c is going to be negative 2. Make sure you pay attention to that negative. So back to the graph of a quadratic. Generally, they're always going to look like a giant U shape. And that shape is also called a parabola. And in parabolas, there will always be a line right down the middle where, if this was on a little piece of paper, like your guys' is, if you fold it in half on that line, the two sides are going to line up right on top of each other. They're going to be identical halves. So that's called symmetry on that line. So that line right there is going to be your axis of symmetry. So because it's a vertical line, straight up and down, we're going to write the equation of that line as x equals, because that's the equation of a vertical line. And so if we go back to that equation that I brought up from the bottom up here, we are going to use our a value and our b value. So the formula for finding your axis of symmetry is going to be x equals negative b over 2a. So in our case, our b value was 6. So we're going to have negative 6 over 2 times our a value, which was 1. So we'll get negative 6 divided by 2 times 1 is 2. So that's going to give us negative 3. So our axis of symmetry, or you can just write AOS, is going to be x equals negative 3. Then from there, if you guys notice, right on the axis of symmetry, there's a point at the bottom where the symmetry starts. So from there, on both sides, that's where they start going up. And that's where they start to look identical, from going off from that point. So that's a very important point to us. So in order to find that, if you guys notice that it's right on top of that axis of symmetry. So the x value of that point, so we need an ordered pair is going to be our answer. The x value is going to be -3. So what we do with that x value is we plug it back into our original equation in order to find the y. So we have y equals, and we have -3 squared plus 6 times -3 minus 2. So we have to make sure, especially this first -3 is in parentheses, because that negative is also getting squared, which is very important. So if we square -3, -3 times -3 is +9. 6 times -3 is a -18. And then we still have that -2 hanging out there at the back. So that is going to equal 9 minus 18 minus 2 is -11. So our vertex is going to be the point -3, -11. And that, ladies and gents, is how you find your vertex and your axis of symmetry. So another reason the vertex is so important is because that will always be our minimum point or our maximum point. So sometimes we'll get the first graph I showed you. So sometimes it'll be that U facing up if our A value out here is positive. That means it'll open up and it'll look like a U. So our vertex, as you guys can see, is our lowest point. So then our vertex, we can call our minimum. Now, if A was negative, then our graph is going to change and it's going to open downwards. So it'll be an upside down U. So in this case, our vertex is still going to be right there, but now it's our highest point on the whole graph. So now our vertex is going to be our maximum. So the vertex will always be the highest point or the lowest point. So I just gave you a little hint about what A does to the graph. It determines whether it opens up or down. But tomorrow we'll use Desmos a little bit in class. We'll get to play around, plug in some different numbers, and see how each of those three values, A, B, and C, affects the graph. So we'll take a look at that tomorrow. But for right now, so we already did the first example and found our axis of symmetry and our vertex. So now looking at the second one, our A value is out in front of the x squared, which is -2. Our B value out in front of the x is -8. And our C value, that number all the way at the end, is just 1. So I would always start with the axis of symmetry because we need that in order to find the vertex. So that's always going to be -b over 2a. So if we take our b and our a that we found, that's going to be +8 because we have a negative and a negative, which is going to give us a positive, over 2 times -2, which will give us -4. And that equals -2. And remember, we have to write that as an x equals equation because that's the equation of a vertical line. So that's our axis of symmetry. Then to find our vertex, we just plug that back in for x into the equation. So we have -2 times -2 squared, make sure that's in parentheses, minus 8 times -2 plus 1. So if we do that math, -2 squared is going to become 4 minus -8 times -2 is positive 16 plus 1. And then if we combine all of that, we're going to end up with y equals 9. So then our vertex is going to be -2, 9. Then our last example, it's not too bad. Our a value is going to be 2. Our b value is going to be -6. And our c value is going to be -3. So to find our axis of symmetry, all we do is take -b. So a -6 is going to be a positive 6 over 2a, and a is 2, so 2 times 2 is 4. So that's going to equal, if we simplify it, 3 halves. So our axis of symmetry is x equals 3 over 2. And then next we have our vertex. And remember, all we have to do to find our vertex is plug that x value back in for x in our equation. So we'll have y equals 2 times 3 halves squared minus 6 times 3 halves minus 3. So 3 halves squared, we square both the top and the bottom. So we'll have 2 times 9 over 4, 3 squared over 2 squared, minus that 6 and the 2 can simplify down to a 3 times, we still have that 3 on the inside, minus 3. So then again here, our out in front, the 2 and the 4 can simplify down to just a 2 on bottom. So we'll have 9 over 2 minus 9 minus 3. And if we type that in our calculator, we'll get -7.5. So then our vertex, I'll write it up here for some more space, is going to be 3 halves -7.5. And these can be in decimals or fractions. Doesn't matter either way. And there you have it. Hope you guys have a great night.